Hello everyone, Kaarel here again from Cybertech Postgres Consulting, coming to you with another set of topics on our Postgres monitoring tool called PGWatch2. And today we're going to talk about some advanced features, concepts, as we've already covered the basics in the previous episodes. So let's just jump right in, and let's start with the different DB types, or basically configuration units that you need to specify. Actually, what do you want to monitor? And this thing is also, of course, the most important points are documented, so you can later dig in even deeper. But basically, what is it about? So if you look at the configuration item, so you need to specify the type, and by default we are monitoring everything per database. This was initially the only way, but over the time, of course, so we found it limiting, and we added a bunch of those. So what do they do? So secondly, we have Postgres continuous discovery. Well, the name is a bit unfortunate one already, I think, but basically here you can specify then connect information to your instance now, and we will continuously scan for databases in that instance, and everything will be automatically monitored. And additionally, you can specify some regexes to include or exclude some databases as you see fit. So you do not have to monitor all of those. But on the storage level, though, still all the databases are separated. So there is no instance level storage. So in the end, all the metrics are per database. Although they will have also some instance-based metrics, but in that sense, there is no real sharing on storage level. Then we added a PG bouncer, and later on, quite recently, actually also PG pool tracking. So what do those tools provide us? Well, some internal statistics on how many queries are being executed basically per second, let's say, and you can see how many users are connected and what's the traffic rate. So this is also quite well actually illustrated here in the advanced features section. For example, yeah, so this is how a PG bouncer dashboard would look like. So you can see if your pool is really limiting something or not. Do people need to wait to get a connection? And similarly for PG pool 2 also, here it's actually even more interesting a bit. So you can, if you're doing load balancing, you can really see how the traffic is distributed, and yeah, if everything is up and running. So here we see that, you know, one node is not really running. Okay, so then we have a couple of DB types related to patroning. Here there is a short description also what patroning is, if you've never heard of it. And basically it's a high availability manager or a cluster manager for Postgres, one of the most popular ones, and maybe even the best one. And yeah, so definitely if you need something like that, check it out. Hugely popular. So patroning, yeah. And here also you can set up tracking per single database, or you can also again track all the databases of all instances of a single patronic cluster. And what's so special here about those Patroni clusters is that you know it's like a dynamic environment when you're using a cluster management, and the nodes mostly usually replicas, you know, they can come and go, and meaning so it's hard to keep the configuration maybe up to date otherwise. So we look into this consensus store or configuration store basically for Patroni, and extract the connect information to currently active nodes, and then we start to monitor them. And very recently also we've added another DB type for Patroni, meaning you can basically monitor everything, all clusters of a Patroni consensus store. So here though we only support etcd as we internally use it the most. So Patroni supports some other configuration stores also. But yeah, basically you just now need to configure one entry for PGWatch2, and all your Postgres infrastructure will be automatically monitored from now on. Also the databases that you know are added in the future. And again, you know, you can provide those regexes if you don't really want stuff with test in the name or something like that. Good. So that covers it, I think. And or maybe let's do a demo also. So here I've got like a small config file. What was in there? So yeah, the default DB type is Postgres, but if we add there Postgres continuous discovery, so we can remove this DB name part, and we can see that, you know, so yeah, I don't want to show this feature yet. So let's save and run PGWatch2, and we will see that, you know, we get lots of information. So let's just stop it, you know, some dummy databases, some PGWatch2 storage databases. So we see that, you know, some pgbench database. So we're monitoring now all of those. So the next topic would be then server log parsing, if I'm correct. Yes. So server log parsing also, like maybe I added like a year ago or so, is another advanced functionality that you cannot probably benefit from always. So it's intended for mostly for those cases where you run the collector directly on the database server, meaning like a push based deployment model. And then basically it's pretty simple, especially if you use like a privileged user. You just need to enable the metric, and this was already visible also here. I'll remove this discovery stuff. I do not want so much stuff here. Postgres, and yeah, so basically you just need to define a custom metric, or yeah, here I mean I'm just providing it, overriding the preset config, because I don't want to see all this other information also. Although server log parsing is already included in this full preset. So basically what you need to do is just you know, you need to pick like a grouping interval. So parsing will happen in real time. So we kind of tail the server log and extract the event severity counts basically, and the database name also. So And this is so this is just a grouping interval. So let's reduce it a bit, like in seconds. So every 15 seconds we should have an entry in the metrics DB how many events, you know, with severity error, for example, happened. And let's start it then. So yeah, we see that it worked. You know, we're storing some information already into the metrics DB. It's gonna be probably all zeros. So let's verify that. Database pgwatch2 using influx storage here. So show measurements, select everything from server log event counts, and we're gonna see just a bunch of zeros here. Maybe let's just, you know, to make it clear, let's drop measurement. So let's stop the collector and let's drop the. So we have nothing now, and now let's start it. And yeah, we see all zeros. And of course, if we would, you know, do it would create some errors. PSQL, So we should already get some non-zero counts with the next grouping interval. So here we need to wait a bit more. 15 seconds was our interval. So now, yeah, we see now that, you know, one error occurred in our database, and there's a separate column for instance total level errors or fatals or yeah, no warnings or panics. Yeah, panic is kind of rare. So this was the feature, and basically it's gonna be automatic once you use CSV log destination for your server logs, and you're using a privileged user, meaning like a super user to run the metrics collection, or a normal user with a PG monitor, with the PG monitor system grant available from version 10. But if this is not the case, so that meaning that the user cannot really ask or discover those Postgres configuration items, like the log folder location, and we're using some custom log line prefix. So you actually do need to specify those. And if you want to see how it's done, so there is a log. There is some information here. Yeah. So how to provide some regexes to parse out this error severity and the database name. But otherwise, yeah, so no big problems expected. Demo. And if you want to see how it looks like actually in Grafana, we also have one like small dashboard on that. Log, if you search for log, server log events. So let's increase the font a bit. So yeah, here you'll see that, you know, the counts in time, and there were some fatals and errors, and so we're getting quite a lot of fatals here actually for our demo site. So 9,000 within last 6 hours. So maybe someone is, you know, brute forcing his way into the database. In this case, of course not. So it's some dummy test script. Okay, server log parsing was that. One more notice. So if you're using some very rare language setup, let's say, you might actually get some weird warnings, and you might not get any data, as we cannot then recognize those severity levels. and you might need to go and change the code then. But for 90% of users, it should just work out of the box. Good. Next topic. Oh, sorry. Prometheus scraping. So originally Postgres, just was fetching some metrics and storing them in a metrics storage database, as we could see from here. So, like a real database. But as Prometheus is very popular, so we decided to add also support for that, and this means, of course, that we are not really storing anything. Everything is controlled by Prometheus, and also the fetching intervals. And on PGWatch2 side, we just need to say what metrics do we want to expose over this scraping port. And yes, everything else happens via Prometheus. And how to enable this? Well, just you need to basically say that data store Prometheus, and that's about it. So then we are not storing anything, and you will have a port for scraping. And additionally, you can also say that, you can prefix. You can decide to prefix all the data points. And you can also specify the listing addresses. So here an example, basically, if you would go in and in our sample case. So let's turn back to let's switch to basic monitoring, and then we say data store equals Prometheus. So that should be enough. And now we're basically ready for scraping. So yeah, crawl silent localhost 9087, I think, metrics. Yeah, so we see now some wall parameters, and yeah, some built-in Prometheus metrics also, basically. But if you do not care about those, so yeah, now we see that TV statistics, transaction counters, and this type of stuff. But yeah, so it's not overly popular, I guess, with PGWatch2. But it can be handy in cloud environments, of course. Also note that PGWatch2 can throw away some columns, as basically Prometheus can only store numeric values. Okay, that should be an easy thing to set up. Then we're I'm just highlighting here again this feature, built-in feature into the collector called like a statistics port or a health check port. And basically, it's obviously not very advanced, an advanced feature, but it can be used actually to monitor also PGWatch2. So this is the question about monitoring the monitors, or who's guarding the guardians. And basically, yes. So you might, for important stuff, you might want to also check periodically if PGWatch2 is doing fine. Can it write metrics to the storage? Are there some too many errors happening during fetching? Maybe some privileges were stripped or whatnot. And for how long has the collector been successfully running? So good. Then next feature, direct operating system statistics. So we covered this a bit also in the previous talk, and basically it has to do with this part here. This normally how you would get system metrics is via those PL Python helpers on a remote database. Yeah? So we want the CPU and the operating the memory information, disk information, and such. Given we do not want to integrate with the other infrastructure of the company or the cloud provider, and we want everything in our grasp. So yeah, for remote databases, this is pretty much the only option. But if you're again using this push deployment model, meaning the collector is here on the database server, so we can of course look at the CPU and the memory information directly. And exactly this is the feature for that. So if you look at the PGWatch2 help, so it says direct or stats, and basically you just you need to set it to yes or on or and then whenever we encounter a metric called PGWatch2 metrics PSUtil something, so those 4 and also some CPU load or something, yeah. So we're gonna just instead extract it directly from the operating system, not via Postgres, as all the normal metrics. Oh, well, a nice feature, meaning we do not need Python, yeah. PL Python, and we do not need the PSUtil library also for Python, and we do not need to additionally stress the Postgres instance. Good. Next feature, performance flags. Well, not a real feature, but basically you can apply some small tricks on storage level and on caching with caching. So you can for example say that your storage is somewhere far away and you want to write in bigger batches. So by default we are waiting. So we're writing 4 times per second. So if your managed data metric storage database is around the globe, it can be like it can introduce too much latency, and it might feel laggy. So yeah, maybe it's okay to lose like if PGWatch2 crashes and burns. So maybe it's okay to lose 1 second of metrics. So yeah, definitely you can increase it, but watch out for some hard-coded limits also. So not to strain the storage too much and not to allow too big batches. So we have also like a cutoff point on 1000 metric points. Connection pooling. So by default we always open a new connection when the interval, when you have like a 1 minute interval, we reconnect with the database. In push configuration, this is of course not a problem at all. But for remote databases, again, this could introduce some latency, some extra load, and you can decide to cache or use some pooling of connections. But yes, so in some environments, so I've seen it not working also optimally. So this would need some improvement, probably. And then there's instance level caching, meaning the PGWatch2 agent can actually detect if those databases that you're monitoring are living on the same instance. For example, here I've got some Postgres instance running in the background for my notebook, and yeah, we can see there's a bunch of databases. And if I would now use this continuous monitoring mode, Postgres or PGWatch2 would then grab metrics exactly and the instance level metrics, basically like the wall location and the CPU load and this type of stuff. So it would grab it. It would grab the same data basically for each of those databases. So this is a bit stupid, of course, if you've got lots of the databases in an instance, well, which theoretically should not be the case for important production databases, but in test environments, of course, it's very common to do something like that, and we would be just doing a lot of stupid work basically. So yeah, you can say that by default actually we are already caching. So but you can say that just increase this caching interval. So we are by default we are caching for 30 seconds, for example, CPU load and such. It could be even maybe too much, yeah. So then you can decrease it. So yeah, then we fetch it once for the first database, and the other one would get the cached value for CPU load or wall location. Good. Do we have something else? The last feature. It's also pretty obscure and little used. But the general idea is that when you're starting up with PGWatch2, you might be wondering how much data will it actually generate for the configuration of my choice. If you want to monitor everything and very aggressively and for like 100 databases, it obviously can get pretty costly. Yeah? So you can actually estimate it by just starting like a dummy test data generation. So we would fetch some data, and then we would just multiply it, and per days or per interval that you have specified, actually with real intervals from your configs, and for how many hosts that you also specify. And yeah, then we just store it in the metrics database, and then you can see how the metrics database behaves. Does it survive this huge influx of data? So yeah, basically like a pretty cool thing. Test data days, so 1 day, for example, and this data multiplier, meaning for how many hosts. So 1 host, and the config, and let's add some verbosity, and basically okay, now it complains that we have not specified connect information. So here we used basically the ad hoc mode, which is by the way also just for normal PGWatch2 or cloud usage or throwaway usage, quite beneficial. So you can specify a connect string without any config files, just via this one parameter or via environment variables. So we want DB name equals Postgres. We want to just monitor this database, and configuration is missing also. How often we want to monitor, or what intervals or what metrics. So basically for that we can use a predefined some predefined preset metrics. set, and these are called, you know, basic, for example, or minimal. And now it should work, I hope. Yeah, sorry. So the config file needs to go there. Yeah, so I mean, this is a feature that you won't be probably using too much. But here we see that, you know, we just now hammer the storage, and after some time it should be ready. Yeah. And now you can also maybe open some Grafana dashboards and see if the feedback is fast, if the response is fast. And this is the idea for this test mode. But yeah, nowadays I even think maybe it was a mistake including it at all, and would maybe make more sense to have it as a separate tool. Good. Okay, so I think this was all for today. Yes, indeed. So again, in case of any questions, feedback, please post it at our project's GitHub site. So thanks for listening. Bye bye.